Greetings. I will be presenting Chapter 11, Section 3, which will be talking about fundamental trigonometric identities. Our objective is to simplify and verify trigonometric equations and/or expressions using the fundamental trigonometric identities. These are the fundamental trigonometric identities. We have reciprocal identities, tangent and cotangent ratio identities, Pythagorean identities, and negative angle identities. Prove each trigonometric identity. We want to prove that tangent of theta is equal to secant over cosecant by transforming secant over cosecant into tangent theta. I recommend duplicating this video onto another window so you can refer to the trigonometric identities there. To continue, the reciprocal identity of secant is 1 over cosine of theta. Cosecant is equal to 1 over sine of theta. We divide the two fractions, making it 1 over cosine times sine of theta. Sine over cosine is equal to tangent of theta using the ratio identity. We more often want to turn the complicated side of the equation into the simpler side, like how we turned secant over cosecant into tangent at the previous example. For this equation, we will modify the right-hand side. Using the reciprocal identity, cotangent of negative theta is equal to 1 over tangent of negative theta. If a trigonometric function has a negative theta and you modify it to its reciprocal identity, the negative theta carries over, like how the negative theta of cotangent carried over to tangent. Continuing on, tangent of negative theta is equal to negative tangent of theta using the negative angle identity. 1 over negative tangent is equal to negative cotangent theta using the reciprocal identity. Simplify it, making it 1 minus cotangent theta. For this equation, the more complicated side is the left, so we choose that side. Turn sine into a fraction, and cotangent is equal to cosine over sine using the ratio identity. We are multiplying fractions, so we can cross out both signs and be left with cosine over 1, which is just cosine. Remember, if you get stuck, try to convert all trigonometric functions into sine and cosines. We want to rewrite this expression so that it is only made up of cosines and we simplify it. We turn secant into 1 over cosine with reciprocal identities, and according to Pythagorean identities, cosine theta squared plus sine theta squared is equal to 1. So if we subtract sine squared on both sides, cosine squared is equal to 1 minus sine squared, which is why we substitute 1 minus sine squared with cosine squared in this expression. Multiply both of them, and we get cosine squared over cosine theta. Using the properties of exponents on division, we can simplify it to cosine theta. We want this expression to be made up of sines and to be simplified afterwards. Remember what I told you a little while ago? By messing around with the Pythagorean identity equations, cosine squared is equal to 1 minus sine squared. As you can see, you can treat the functions as numbers or variables, so you can factor the difference of two squares. The 1 is not squared, but you can make it 1 squared, since 1 squared is still equal to 1. You cross out the common factors, and ta-da! You simplified it to 1 plus sine theta. Have a daily dose of physics grad questions. At what angle of a concrete incline will a wooden block start to move if the coefficient of friction is 0.62? We set the weight component expression equal to the force of friction expression. We divide both sides by mg. That weird-looking u is equivalent to a lowercase m in English from the Greek alphabet. Continuing on, we substitute 0.62 for m. Divide both sides by cosine. With the ratio identity, we can modify it to tangent of theta. We solve for theta by multiplying the inverse of tangent with 0.62. Theta is equal to 32 degrees. The block will start moving if the concrete incline is at an angle of 32. That is all. I hope you know how to simplify and rewrite equations and expressions using trigonometric identities. And forgive me for some of the dog barking. My neighbor has 10 plus dogs. What am I supposed to do about that? But thank you for watching.